Hi, I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In the present video, I would like to discuss the topic, the problems on volume integrals. In the previous video, we have seen the volume integrals, the formula, and we have done some problems on volume integrals. So in this video also I would extend my topic on volume integrals problems. So here we have to consider the three-dimensional vision picture, and we have to consider the limits for integration x, y and z. X is for length, y is for breadth and z for height limit. So based on that we have to find integral f bar dv or div f bar dv, whatever it is, the volume integral can be calculated. So now in this video we see some examples how to solve the problems on the triple integration. So here, given that phi of x comma y comma z is equal to 45x square y, clearly it is a scalar function, and you are supposed to evaluate triple integral phi of xyz dx dy dz, where v is the closed region bounded by the planes 4x plus 2y plus z is equal to 8, x is equal to 0, y is equal to 0 and z is equal to 0. So clearly given that the planes are x0 means it is a yz plane, similarly y0 means it is zx plane in three-dimensional coordinate system, z0 means it is xy plane. And another plane also given 4x plus 2y plus z is equal to 8. So this is a plane where z-axis intersect at 0, 0, 8 and x-axis intersects at 2, 2, 0, 0 and y in 0, 4, 0, 0, 4, 0. This is a plane and shown this is 4x plus 2y plus z is equal to 8. So now we have to find the volume integral, triple integral phi dx dy dz, where v is the region bounded by these planes, that is x plane, xy plane, yz plane and zx plane, and one more plane is given, that the plane equation given as 4x. So what is one more plane given as 4x plus 2y plus z is equal to 8. That means what? The intersect form on x-axis is 2, 0, 0. So we can write this as 4x plus 2y plus z is equal to 8 as x by 2 plus y by 4 plus z by 8 is equal to 1. So it touches x-axis at 2, 0, 0, y-axis at 0, 4, 0 and z-axis at 0, 0, 8. Now to find the limits of integration, we have to consider the strip inside the region parallel to z-axis and taking the strip parallel to z-axis. And moreover, we know that on xy plane z is equal to 0. This is xy plane. On xy plane z value 0 and this variable surface is z is equal to 8 minus 4x minus 2y. So that is the limit for integration. Z is a variable limit. Z varies from 0 to 8 minus 4x minus 2y. The z is a height limit. So we know that to find the volume, we need length, breadth and height also. So the height multiplied by area is also volume. Volume is nothing but length into breadth into height. Or length into breadth is treated as area. Area multiplied by height also gives volume. So area means, suppose if you consider this area in xy plane multiplied by height will give the volume. So the height is 0, 2, 4, 8 minus 4x minus 2y. That is the length or height limit. And on considering to the area limit, we should consider in xy plane, that is 4x plus 2y is equal to 8. The line is 4x plus 2y is equal to 8. So on taking the strip parallel to y-axis, x is equal to 0 here. And on putting x to 0, you'll get to, what you will get, 4x is equal to 8 minus 2y, or 8 minus 2y by 4. That is the limit for, on x-axis y0, y0 to, this is y8 minus, so I will write here, y0 on x-axis y0, y0 to, what this is, I'm putting y is equal to 8 minus 4x by 2, or we can write it as 4 minus 2x, y is equal to 0 to 4 minus 2x. This is y limit. Y varies from 0 to 4 minus 2x, and z varies from 0 to 8 minus 4x minus 2y, and x is a constant limit which varies from 0 to 2. These are the limits for the integration for the tetrahedron. So now we have to calculate triple integral phi of x, y, z, dx, dy, dz. Now, so I'll go to the next slide. Now, triple integral phi of x, y, z, dx, dy, dz is equal to triple integral. So what is the function? 45 x square y dz, dy, dx, and z limit is varies from 0 to 8 minus 4x minus 2y. That is z limit. Z varies from 0 to 8 minus 4x minus 2y, and x also varies from 0 to something, and y also varies from some 0 to, what is y 0 to 4 minus 2x, y 0 to 4 minus 2x, and x is equal to 0 to 2. So these are the limits for the integration. First we have to set up the limits of integration. Because the region of integration is the tetrahedron, we have height limit and breadth limit and length limit. So length, breadth into height will give the volume of the given region. So because this is a function and this we have to integrate with respect to z first, because z is a two variable limit, on integrating you'll get integral 0 to 2, integral 0 to 4 minus 2x. So what will be the function? 45 x square y integral dz, that is z between 0 and 8 minus 4x minus 2y. The limits are these two into dy into dx. Now on substituting the limits 0 to 2, 0 to 4 minus 2x. So what you have to substitute? 45 x square y as it is. Upper limit is 8 minus 4x minus 2y. Lower limit 0 of dy dx. So upper limit z, instead of z I am substituting 8 minus 4x minus 2y, and lower limit is 0. 45 x square y is constant. So now on simplifying the integrand, so what is the 45 into 8? What is 45 into 8? 8 5s are 40, 8 4s are 32 plus 4, 36. 360 x square y, that is the first term. And second term, 45 4s, 45 2s are 180, 90, 92s are 180, x cube y minus 45 2s are 90 x square y square of dy dx. So now, I'm integrating with respect to x again. So this is y, this is x. So sorry. So we have to integrate first with respect to y, because y limit is a single variable limit which varies from 0 to 4 minus 2x. Now on integrating with respect to y, what you will get is 360 x square y square by 2. The x term and constants are all always treated as constants. And here also 180 x cube. So y square by 2. That is the integration for y. And here also 90 x square y cube by 3 between the limits of 0 and 4 minus 2x of dx. So on simplifying 2 into 2 180s are 360, 2 90s are 180, 3 30s are 90. So what do we write? So I'm writing the same term here. So integral 0 to 2. So what is the term to substitute? Instead of y's, I have to substitute 4 minus 2x. So 4 minus 2x whole square minus 90x cube into 4 minus 2x whole square minus 30 into x square 4 minus 2x whole cube, lower limit y 0 0 0 0 of dx. So this I can write. So 0 to 2, what I can write? 4 minus 2x whole square is a common term in all the terms. So 180 x square minus 90 x cube minus 30 x square into 4 minus 2x of dx. So this is integral 0 to 2. So 16 plus 4x square minus 2ab. That is what you will get? 16 minus 16x. So this is the term. And here also 180x square minus 120x square. So there is a difference 60x square. 180x square minus 4 3s are 120x square. That is 60x square. And another term minus 90x cube and minus 32s are 60 minus plus 60x cube. Am I right? Minus 90 plus 32s are 60x cube. That is minus 30x cube. Minus 30x cube of dx. So now on multiplying integral 0 to 2, what you will get? So you can take out 30 outside. You can take out 30 outside. You can take 4 also in this. 4 also in this. You can get 4 4s. 4 x square minus 4x. Minus on 30 I am taking out 2x square minus x cube of dx. So this is equal to, what I can write, it is 120 into, so what I can write here, we are almost in the final integration. That is what you will get, 120 into integral. So what you have to write, 0 to 2, the multiplication. Here is what you will get, 4 2s are 8x square. I will simplify and I will write the resultant term here, minus 4x cube and plus 4 2x power 4 minus x power 5 minus 4 2s are 8x cube plus 4x power 4. So what you will get? Minus x power 5 plus 6x power 4 minus 12x cube plus 8x square. This has to be replaced. So that is minus x power 5 minus x power 5 plus 6x power 4 and minus 12x cube plus 8x square. Minus 12x cube plus 8x square of dx. So the final stage of the evaluation of the integral 120. So finally you have to integrate with respect to x. So x power 5 integration x power 6 by 6 and x power 4 integration x power 5 by 5 minus 12 into x cube integration x power 4 by 4 plus 8x cube by 3. The limits are between 0 and 2. So I'm substituting 120 into, so what is 2 power 6? That means minus 64 by 6 plus 2 power 5, 32. 6 into 32 by 5 minus 3 into 16 minus 48. 4 3s are 12. 3 into 2 power 4, 16, 18 plus 3 into 2 cube 8, 64 by 3 and lower limit is 0. That is 120 into minus 64 by 6 plus 30 to 6 are 6 2s are 12, 6 3s are 18, 192 by 5 plus 64 by 3 minus 48. So on simplifying, the value is 356. The LCM is 30. The LCM is 30. So 6 5s. So you can write it as 120 into 564s. 320 minus 320 first term plus 5. 5 2s are 10, 5 24s, 5 2s are 10, 5 4s are 20, 24 into 192. So multiply this value, 192 into 24 plus 64, 340, 40 into 64, 64 into 40 minus 48 into 112. So this will give the required solution of the given problem. So I'm simplifying, this is giving as an exercise for the students. And simplifying, we'll get the required solution. So similarly, you can do the another problem. Here, how to integrate, what is the region of integration to be considered? That is the most important thing. Integration is already, you know how to integrate the triple integral. So how to take the limits, that also you have to consider as a serious part. And the remaining are all well-known things. Similarly, we do another problem. Here also we have to integrate the triple integral or volume integral, integral f bar dv, where f bar is equal to xi bar plus yj bar plus zk bar, and v is the region bounded by x is equal to 0, y is equal to 0, y is equal to 6, z is equal to x square and z is equal to 4. So I can say that x0, y0, you know that all the things are. So I will explain again. What is x square is equal to z? X square x is equal to z indicates a parabola in xz plane. Suppose if it is x and z, so x square is equal to z will be like this. This is the parabola. X square is equal to z. It is like x square is equal to 4ay. X square is equal to 4ay. Suppose if it is even powers of x, it is symmetrical about z axis. So x square is equal to z. This is looks like it is a parabola. So now the limits of integration z4 to z is equal to x square. So z is equal to 4, z is equal to 0. This is z1, z2, z3, z4. This is z is equal to 4 line. z4 to x square means the strip is like this. Z is equal to 4 to, this is the parabola, z is equal to x square. The strip is considered in the parallel to z axis. So z limit is a variable limit from x square to 4. That is z limit. Z varies from x square to 4. The region is bounded by the straight line z is equal to 4 and the parabola z is equal to x square. And y varies from, this is the area limit. Area limit means z varies from x square to 4. And moreover, the intersection point of the two curves. What is the two curves? Z is equal to 4 is the one curve, and Z is equal to x square is another curve. That means what? X square is equal to 4. So x is equal to plus or minus 2. That means what? There exist two contacts here. One is minus 2 comma x minus 2 and y is equal to 4 and plus 2 comma 4. So Z x2 and minus 2. So the intersection points are 0, 2 comma 4 and minus 2 comma 4. But the area restricted to x is equal to 0 only. That means the region of integration is this part and it is parallel to y-axis. Parallel to y-axis means x, y, z. Then the region of integration will be like this only. And this is a three-dimensional vision of the curve. And this is the part of the region. This is the volume of, we have to find the volume of this part only. Because x is equal to 0 means this is x0. One boundary is z x square to 4. And x0 to what is constant limit? X is equal to some 0 to, how will you get the limit? This limit. Z is equal to x square to 4, you will get the strip area. So strip area, this point to this point I have to wear. This point means 0 comma 0 and this is 0 comma 0. So x0 to 2. x0 to 2 is the limits for integration. All of it clear, I think. Z is equal to x square by x square by 4. This is the strip area. This strip area has to move from this point to this point. That means this is 0 comma 4. So x0 comma 2. x0 to 2 will vary. Then you will get the area. Area of this region. Area of this region you will get. If you do the region area, so by assuming this what we call it as y limit vary from y is equal to 0 to y is equal to 6. You will get the area. This is this portion. Height is 0 to 2. This is the part of the region. This we have to find out. This is the portion. We need to calculate this portion. So this is the part of the region we have to calculate. So y varies from 0 to 6. So the limits for integration. Y 0 to 6, z x square to 4 and y x varies from 0 to 2. So now the problem is, what is the problem? Integral f bar dv. Already f bar given. So I will write now our required integral f bar dv over v is equal to f bar is xi bar plus yj bar plus zk bar. This is a dx, dy, dz and over the volume v. So this can be treated as triple integral x0 to 2 as per our region. Already we have calculated the limits and y0 to 6, y limits are also constant limits. Z varies from x square to 4, xi bar plus yj bar plus zk bar of dz first, dy next and finally with respect to dx. So we are supposed to integrate the vector point function with respect to z first because z is the two variable limit and x and y are constant limits. So we can do integration with respect to x and y or y and x. So both are no problem. But you have to integrate the function first with respect to z. So now I bar into, so it is 0 to 2 and it is 0 to 6. This is 0 to 6. So x into dz into dy into dx plus j bar into same integral 0 to 2, integral 0 to 6, y dz dy dx. So this I have to write 0 x square to 4. This also x square to 4. Just I am splitting the interval. I am not doing any integration here. Plus the same limits 0 to 2, 0 to 6 and x square to 4. The function is z dz dy into dx. So now on integrating I bar into integral 0 to 2, 0 to 6. So the x integration with respect to z is xz. Because when you are doing integration with respect to z, x treat as constant. X into z limits x square to 4 dy dx. The same limits of integration for all the three cases. Just the function is varying 0 to 6, and here yz between x square and 4 and dy into dx plus integral 0 to 2, integral 0 to 6. So z square by 2. Here the integration is with respect to z and the function also z. So this is x square to 4 and dy into dx. Now what is the integration? I bar into, now substitute the limits 0 to 2, 0 to 6. So upper limit 4x, and replacing z for 4, 4x minus z for x square means this is x cube dy dx plus j bar into, what is j bar here, k bar, j bar into integral 0 to 2, integral 0 to 6. So replace z for 4, that is 4y minus x square y dy dx. That is the second term. And third term plus, I will write integral 0 to 2, integral 0 to 6, 1 by 2 constant. Also there is k bar also, k bar by 2. Upper limit 4 square by 2, 16 by 2. 16 by 2, that is equal to 8 minus x square whole square, x power 4 by 2 into dy into dx. So I write in fair mode. So just copy down from the previous slide. Dy dx, z with respect to z already integration over, and we have substituted the limits and we simplified the value, then we get this. Now I bar into, undoing the integration with respect to y. So first term 4x minus x cube as it is into integral y between 0 and 6 of dx. 4x minus x cube, the entire term is a constant term with respect to y. So 4x minus x cube treat as constant term, integral dy y between 0 and 6 dx plus j bar into integral 0 to 2. So on integrating with respect to y, 4y square by 2 minus x square y square by 2 between 0 and 6 of dx plus last term k bar into integral 0 to 2 integral. So on doing integration with respect to y, so we'll get 8y minus x power 4 by 2 into y between 0 and 6 of dx. 8 minus x4 by 2, it is also constant, integral dy is y between 0 and 6. So what we will get here, I bar into integral 0 to 2, upper limit 6, lower limit 0. So what we will get, 6 into 4x minus x cube of dx first term plus j bar into integral 0 to 2. So this is 6 power 2, 6 square, 36 to 72 minus 6 square, 36 by 2, that is 18 x square, lower limit is 0 dx plus k bar into last term 0 to 2. So y, instead of y you can write 6. So 6 on taking outside, 8 minus x power 4 by 2 lower limit 0 of dx. So instead of y I am putting 0 lower limit, the entire term 0. Only upper limit will get, the upper limit is 8 y on taking outside, 6 into 8 minus x power 4 by 2. of dx. So now I can do the integration I bar into 24x first term. That means 24x integration x square by 2 minus 6 into x cube. That is 6 into x power 4 by 4. The limits between 0 and 2. Almost we are in final step. Plus j bar into what is 72x first term, 18x cube by 3 between 0 and 2, and the last term k bar into 6, already you can write outside 6k bar into 8x minus x power 5 by 5, already 2 is there, it is 10 between 0 and 2. So just integration with respect to x, finally line integration. So this is 2 12s are 18, 24, sorry, 2 12s are 8. Now I'm doing the integration, I bar into, integration already over, just I'm substituting the values. 12 into 2 square, 4, that is 48 is the first term, minus, so 2 power 4, 2 power 4 is 16, 16 into 6 by 4, 4 4s are 16, so 4 6 are 24, that is the second term, plus j bar into 72s, that is 144 minus 18 into 8 by 3, that is 144 by 3, 18 into 8 by 3, or you can write 3 6 are 18, so 6 8s are 48 I think, so you can write directly 3 6 are 18, 2 6 8s are 48, just simple over. The last term will get plus 6k bar into, this 8 2s are 16 minus 2 power 5, 32 by 10, lower limit 0. So then what is the coefficient of I bar is 24 I bar, that is the final answer I am writing, 24 I bar, and 144 minus 48, so 44 means 100, 96 plus 96 j bar, and what this is value, 160 minus 32 by 10 into 6. So 160 minus 32 means 128 by 10 into 6. So 2 3s and 2 5s, and 8 3s are 24, 3 8s are 24, 3 2s are 6 plus 2, 8, 3 1s are 3 plus 2, 584 by 5 plus 584 by 5 into k bar. That is the required solution of the given triple integral. Just you see the model f bar dv, integral f bar dv. The limits varies from z is equal to x square to 4, y 0 to 6, x 0 to 2. So substitute all the, just to integrate first with respect to z, then with respect to y, then finally with respect to x. So on substituting and integrating, you'll get the required solution. So this is the way of doing the integration in volume integrals. So in the next session, we will see the integral theorems. There are 3 theorems. One is Gauss divergence theorem, and there are 3 theorems. One is Gauss divergence theorem, and then Stokes theorem and Green's theorem. So these 3 are the relation between the line, surface and volume integrals. And if you know all the 3 models, that is line integrals and surface integrals and volume integrals, then you can solve the problems under these theorems. These 3 are called the vector integral theorems. And one is the theorem shows the relation between the line and surface and volume and the surface integral. And these theorems can be explained in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.